consider the curve y is x minus 4 divided by ax squared plus bx plus c, where a, b, and c are non-zero constants. The curve has a local minimum point at 2, 1 and a vertical asymptote with equation x is 1. Find the values of a, b, and c. So, since there are 3 unknown values, a, b, and c, in general, we need what? 3 equations to be solved to find the required values of a, b, and c. It is given that there is a vertical asymptote, and we know that a vertical asymptote arises from what? Division by 0. So, denominator, when x is 1, must be equal to 0. It will be the first equation. The second, we know a point which belongs to this function, so just substituting 2 for x and 1 for y, we can get the second equation. And the third can be obtained from what? There is a local minimum, and we know that local minimum or maximum, what is the necessary condition? Derivative at the point must be 0. It will be the third equation. So, the vertical asymptote, substituting 1 for x into the denominator, we get the next, that 1 squared and times 1, so just a plus b plus c should be equal to 0 to get a vertical asymptote at x is 1. The second, just a point, so 1 for y, 1 is x, it's 2 minus 4, 2 squared 4a plus 2b plus c, and it's what? It's negative 2, and rearrange, move it to the left up. It's a proportion. You may do a cross multiplication or any method, so it becomes 4a plus 2b plus c is what? Is negative 2 divided by just 1, so just negative 2. And the third, we need derivative, so derivative, and we can see that it looks like what? It's division, so we should use what? Quotient rule, and it says that it becomes denominator squared, just denominator squared, then in the numerator we get numerator derivative, x minus 4 derivative is just 1 multiplied by just denominator for a, not for ax squared plus bx plus c minus just numerator x minus 4 and multiplied by the denominator derivative, which is what? Just 2ax plus b, and derivative at 1, but we need only 2 because there is only x, so derivative at 2 must be 0. So substituting 2 for x, we get the next, that what? 4a plus 2b plus c minus 2 minus 4, it's negative 2, so plus 2, 4a plus b divided by what? 4a plus 2b plus c squared, and it should be equal to 0. And a fraction is equal to 0 when numerator is equal to 0 and denominator cannot be equal to 0. So let's simplify it. 4a plus 2b plus c plus 8a plus 2b is equal to 0. So it becomes what? 12a plus 4b plus c is equal to 0. So it's the first, the second, and the third. It's question with the calculator, so actually we can solve using a matrix, using a calculator with matrix, but it can be solved without a calculator. Let's consider Since it's simultaneous equations, so we can do the same operations with the left hand side and the right hand side. So let's consider, for example, 2 minus 1. Why? Because I can see plus c plus c, so we can remove c. So 2 minus 1 would subtract the left hand sides and the right hand sides to get, for a minus a it's 3a, and 2b minus b is b, and c minus c is 0, and negative 2 minus 0 is equal to negative 2. And let's consider, for example, it doesn't matter 3 minus 2 or 2 minus 3 or 1 minus 3. Definitely we cannot use 1 minus 2, because we will get absolutely the same as the obtained expression. So let's consider, for example, 3 minus 1 to be more easier. So it becomes, we subtract 3 minus 1. So it's 12a minus a is 11a. For b minus b it's plus 3b, and c is 0, and 0 minus 0 is 0. And you can see that it's easy simultaneous equations with two unknown values. And you can do substitution or elimination. For example, you can say that b is negative 2 minus 3a and substitute for b into the second, but I want to multiply the first by negative 3 to get 3b and negative 3b, and then eliminate b. So it becomes multiplied by negative 3. I can multiply each term by the same value, or divide. And also I can multiply or divide each value in the second if required. So it becomes negative 9a minus 3b is 6, and the second 11a plus 3b is 0. And now I add both sides to get just 2a is equal to 6, and a is 3. A is 3, yes, it's correct. Then from here, b is negative 2 minus 3a is negative 2 minus 3 times 3, and it's negative 11. And finally c, we can use, for example, this, and you can see that c is negative a minus b, which is it's negative 3 minus negative 11, and you can see that it's 8. So a is 3, b is negative 11, and c is 8. And actually, let me show how to solve using a calculator. To solve with the calculator, we should do the next. We need matrix, edit, and it becomes 3 times 4. And the first equation, it's a plus b plus c is equal to 0, and we need just coefficients. So 1, 1, 1, and 0. The second, where is the second? But notice that there must be ABC, ABC, ABC in the same order. So the second becomes 4, 2, 1, and negative 2. 4, 2, 1, and negative 2. And the third, it's 12, 4, 1 and 0. So then again matrix Mars, and we need this one, and our again matrix, no, it's not matrix, and names A, and you can see you will always get like this 1 1 1 and zeros, and 3 negative 11 and 8 are the required values of A, B, and C, since we can see the ABC is equal to something, ABC is equal to something, and hence we get in the same order A, B, C. So you can see A is 3, B is negative 11, and C is 8, and that's all for this question.